Okay, let's look at this question that has to do with hybridization. And we're going to look at a special molecule called phosgene. And just in case you're kind of adventurous, please do not try to make this at home. Okay, phosgene is a pretty dangerous thing. It was actually used as a nerve poison in one of the world wars. Okay, and so you don't want to play around with phosgene. But the molecular formula for phosgene is Cl2CO, and we're telling you that the carbon is a central atom. So before I can figure out hybridization, I first have to determine what the Lewis structure is for this thing. So let's go to the periodic table and see how many valence electrons I have in chlorine, carbon, and oxygen. So if we go to the periodic table over here, carbon has 4 valence electrons, chlorine has 7, oxygen has 6 based on, again, where it is in the periodic table, which group it's in. So that means that if I look at Cl2CO, chlorine has 7, and I have 2 of those. Carbon has 4, and oxygen has 6. So that gives me 10, and 14 is 24 valence electrons total. And I'm told that carbon is a central atom. So I'm going to put the carbon in the middle, and I'm going to connect it to the chlorines, and I'm going to connect it to the oxygen with a single bond for each of them. So now I used 2 electrons here, 2 here, and 2 here. That's 6 total. So that gives me 18 remaining in my bank. Distribute those electrons to the outer atoms so that they have a stable octet, which means that this chlorine gets 6, this chlorine gets 6, this chlorine gets 6, so that's 18. I have no electrons left. So you might think that you're done, but you're not. The reason you're not done is because carbon isn't really happy, right? Carbon wants to obey the octet rule, which means that it has to have 8 electrons surrounding it. And right now, if you count, I only have 2, 4, 6 electrons surrounding the carbon, which would be 6. And I want to give it 2 more. And so the way that I give it some is by taking some electrons that are non-bonded pairs and convert them into bonded pairs. And the best place to get that from is from the oxygen, okay? Because the oxygen is willing to donate them a little bit more than the Cl is. So I can take 2 electrons, and it doesn't matter which 2, and basically bring them into the middle. So now I have a double bond between the O and the C, but the bonds between the carbon and the chlorines are all going to remain single bonds. Okay, and so now everybody's happy. Oxygen and carbon and chlorine each have the right number of valence electrons, and if I calculate the formal charges, they're all going to be 0. Whereas before, I would have had formal charges of +1 on the carbon and -1 on the oxygen. So this is the correct Lewis structure, but that wasn't really what the question asked. The question said, what's the hybridization right here? Okay, the point is that this carbon is bonded to 3 things, right? Number of electron groups is 3. It's bonded to a Cl on the left, a Cl on the right, and an oxygen on top. So because I'm bonded to 3 different objects, this is going to be a trigonoplanar geometry. And to make these 3 bonds all be more or less identical, this has to be sp2 hybridization. So I have to combine 1 s orbital and 2 different p orbitals so that I can make 3 different yet identical sp2 hybrid orbitals.